In this video, we'll be looking at calculations, in particular concentration. Now here's a few things to remember. If you are sitting the higher or triple test, you need to be able to use moles, and there's a video on what this is on the channel. If you're sitting foundation, well, you'll just have to focus on using mass. We also need to be able to convert our units, and we'll have a look at this during the video. We need to make sure we have our calculators, and also show all of our working out. Now, starting off, here's our formula for concentration, where concentration is going to equal mass, or moles, divided by volume, where mass is measured in grams, moles is measured in mole, volume is measured in decimeters cubed, and concentration, well, that depends on whether you're using mass or moles. If using mass, it's grams per decimeter cubed, and if we're using moles, we're going to have moles per decimeter cubed. Right, now we mentioned decimeters. Here's how to convert from centimeters cubed to decimeters cubed. So, to go from centimeters cubed to decimeters, we have to divide by 1,000, and to go back the other way, well, we do the inverse, multiply by 1,000. Here's a few examples for you to try. Take the next minute to give them a go. If you finish early, skip ahead. Here's the answers to those questions. Right, let's have a look at a worked example. Calculate the concentration of 2 grams of sodium in 5 decimeter cubed solution. Right, well, the first thing we need to do is write down our formula, where concentration is mass divided by volume, and then we just need to substitute in our values. We have 2 grams of mass and 5 decimeter cubed of the volume. And then if we put this into our calculator, we should get 0.4 grams per decimeter cubed. Let's have a look at one more. Calculate the concentration of 4.8 grams of sodium oxide in 762 centimeters cubed of solution. Right, the first thing I need to do is convert my volume. So to go from centimeters cubed to decimeters cubed, I must divide by 1,000, which leaves me with 0.762 decimeters cubed of solution. Then I write down my formula with the substituted values, including the new converted units, and then this works out to be 6.3 grams per decimeter cubed. Right, here's 4 questions for you to try. Make sure to show you're working out whilst doing these, and take the next 3 minutes to give them a go. If you finish early, just skip ahead. Here are the answers to those questions. Right, let's have a look at rearranging the formula. If we want mass or moles as the subject, we start off by multiplying each side by volume. This gives us mass or moles equals volume times concentration. Whereas if we want to make volume the subject, well, again, we'll multiply each side by volume and then divide by concentration, giving us volume is mass or moles divided by concentration. Let's apply that formula. Calculate the mass of sodium in 5 decimeter cubed of a 0.62 grams per decimeter solution. Well, here's the original formula. We want to calculate the mass, so we'll do volume times concentration. Substitute the values in. So I've got 5 decimeter cubed multiplied by 0.62 grams per decimeter cubed, giving us 3.1 grams. Here's another one. Calculate the volume of water needed to make a 0.89 grams per decimeter cubed solution of 0.7 grams of salt. Again, we'll rearrange the formula to make volume the subject and substitute in our values. 0.7 divided by 0.89 grams per decimeter cubed, giving us 0.79 grams of our salt. Okay, here's 4 questions for you to try. The conversions and the formulas are found at the top. Take the next 4 minutes to work through these. And if you finish early, as always, skip ahead. Here are the answers to those questions. Right, from this point onwards, it's going to be strictly for higher and triple papers only. Now, starting off, you'll need to be able to incorporate both of the following formulas. Concentration, which we've looked at, but also the moles formula, which we had a look at in a previous video. Here's an example. Calculate the concentration of a 250 centimeter cubed solution containing 6 mole of calcium carbonate. Now, the first thing we need to do is always check our units and convert where needed. In this case, 250 centimeters cubed divided by 1,000 is going to give us 0.25 decimeters cubed. Concentration is going to equal 6 mole divided by our new volume, 0.25 decimeter cubed, giving us 6.3 mole per decimeter cubed. And see here, we're now using the mole per decimeter cubed units because we've used the moles in our calculation. Another example, a solution of copper sulfate is prepared using 9.2 grams of solid copper sulfate, which is dissolved into 16.7 decimeters cubed of water. We need to calculate the concentration in moles per decimeter cubed. And we're given the MR in this question. You are not always given that. Now, what I like to do in these calculations is first highlight the key information I'm given. In this case, I've got 9.2 grams of mass, and I have 16.7 decimeters cubed of water, our volume. And lastly, I have an MR, which is 160, and this is for copper sulfate. Now, the only thing I can now calculate is the moles. I have both the math and the MR. And I just substitute those numbers in. So I'm going to do 9.2 divided by 160 to give me 0.0575 mole. And now that I have my moles, I can now use my concentration formula. Again, start off by substituting my new numbers. 0.0575 divided by 16.7 decimeters cubed, giving me 3.4 times 10 to the power of minus 3 mole per decimeter cubed. Now, you don't have to give your answer in standard form unless specified, but it's good practice. Here's 4 questions for you to try. Take the next 5 minutes to work through these. And if you finish early, just skip ahead. Here are the answers to those questions. Right, so in summary, we need to always check for any unit conversions, and this goes for all calculations, not just this. We need to figure out which formula we're going to need. And please always use a calculator. And lastly, you are only going to get better at these by practicing more examples. Right, that's it for this video. If you have any questions, leave them down below, and I'll do my best to get back to you.